Our AWS project is license plate recognition. For this project, we have used the following AWS services. These services have been used in accordance to this system architecture diagram. The data flow of this diagram is as follows. The user uploads the image. The uploaded image gets stored in the S3 bucket, from where it gets retrieved by recognition for doing the text extraction. The extracted text along with details about the image ID are stored in our DynamoDB table. This consists of our storage. A Lambda function has been defined which allows the flow of data from S3 recognition and DynamoDB to and fro. This data flow happens in accordance to the IAM policies defined by us. An API gateway is set up to trigger the Lambda function from our user interface. And lastly, the user interface has been deployed and hosted on Amplify. Now we'll do a quick demonstration of our web application. We go to our domain URL. This is our user interface. For the demo run, I'll be using this image. As you can see, it's sample image 2. When I upload the same on our web application, it processes the image and then it returns a license plate number. Let's see if these two match. We have used Amazon recognition for this project, specifically the text in image feature. When we upload an image here, you'll see that it will extract all the possible text it finds in the image, like so. So to retrieve the license plate number, specifically an Indian license plate number, we had to devise a regular expression. Now let's see how this is done through our Lambda function. We'll go through the code once. First, we get access to the 3 resources that we'll be using. We initialize our bucket name, the table name, and then we start the actual function. Now, the function first checks if the image has been uploaded. If the image is uploaded, we generate a unique file name for it and we decode it and store it into our S3 bucket. Then this image is taken to recognition and the detected text gets stored in this text detection. As we saw that there will be multiple text detection, we'll have to find the one which is of use to us. We initialize the license plate as an empty string and highest confidence as 0. Now this loop basically iterates through all the detected texts to match it to our needed regular expression and then uses all of those to find the one of highest confidence, which is then stored as license plate. If after this procedure no license plate is found, then we return that there is no license plate in the image. If there is one, then we store the following details in our DynamoDB table. And that's how we get our final output. This Lambda function was tested and debugged multiple times with the help of the CloudWatch logs. So was our API gateway. This is our S3 bucket where all the images get stored with unique file IDs. This is the DynamoDB table where all the highest confidence text or the license plate numbers get stored after the recognition module works. And this is our IAM policy, which initially gave full access to the Lambda function and then we followed the least privilege principle. This is our API gateway where we use the post method. And this is Amplify where we have hosted our website. This is the index file that has been zipped and uploaded on Amplify. This is the basic HTML code, the header, the user interface, the footer. Now this is our main JavaScript code, which first checks if an image has been uploaded when hitting submit. If there isn't one, then it prompts us to select an image first. Once that is done, we display our processing image text and the loading bar. Now in this try block, we use the fetch JavaScript function to call the API gateway endpoint associated with the post method. This triggers our Lambda function and establishes our connection between the user interface and the database. The API we used is a REST API. Once we get the response back, we either display the license plate number we got as the response, or we tell that there's no license plate detected or an error has occurred internally. This is our final user interface. Thank you.